follow-up questions, there's a QR link to it on the screen. And there's also the QR link to my colleague, Stefano Gabaldo. Steph covers Europe and South America, and his information's on screen too. So if you want to take a second to pull out your phone and just grab our contact information, that way you'll have us if you ever need us in the future. I'll just leave that up on screen for another second. Okay, today we are going to talk about what is reverse circulation drilling. If you do have any questions, just hold on to them till the end. I've got about 10 minutes reserved for questions, and you can type in the chat at that point, and I'll go over the chat and kind of group common questions if there are common. And then we're going to talk about how did RC Swivels come about, so why are they a thing? And then another thing we're going to talk about are what components kind of involved with the RC Swivel and what tooling they're paired with. I'm going to go over cluster drills, down the hole hammers, and the reverse circulation auger, which is a new one. We're going to talk a little bit about what drill rigs can be retrofit, and I'm going to talk about the two main RC Swivels that we have here at Berminghammer. So this is a big slide, lots going on here. What we're going to first talk about is what is reverse circulation drilling. I'm getting a little bit of an echo. If someone could just mute, perfect. Thank you. RC stands for reverse circulation, and it is a method of drilling that uses air to drill hard rock and return the cuttings to the surface through the drill string. It differs from direct circulation in that the cuttings are controlled and don't just spray out of the top of the pile being installed. Air goes down to the down the drill string and powers the down the hole hammers that chisel the rock, or the multiple down the hole hammers in the case of a cluster drill. Under a head of water, a vacuum is created, and the air and cuttings move upwards and are directed back into the drill string, up through the rotary, and returned through a discharge hose to a waste storage location. Now, that waste storage location could be a couple of containers. It could be a dump scow in a marine environment. It could be a pit. Again, just a reminder to mute if you're on the call. So on the leftmost.
Yeah, I should be, yeah.
Okay, so yeah, if you want to meet up, we can do that. I can.
Hey, Joel, can you mute?
I'll try to mute as they come in, David, so you keep going.
Okay, so on the leftmost diagram, you see this process in the context of a down the hole hammer. You can kind of see in the orange, the air going down the drill string, down through the down the hole hammer, and then returning with cuttings up through the blue portion, through the crossover, and back up the drill string. The photo next to it is a similar example using a conventional rotary bit. It would be a very similar example using a cluster as well. The photo in the center is the finished product of an RC case advanced installed pipe. And the photo on the right is a Berminghammer vertical travel lead paired with a Berminghammer drill, complete with an RC swivel installing the pile you see in the center. The next slide gives you an idea of what these kind of installations look like. I'm going to give the example of a case advanced installation using reverse circulation drilling. So this is a video taken in France, and it's a good example. You can see in this case that they're just discharging back into the ocean, but it is very common to discharge back into a pit or a container or a dump scow. You can see that the conventional method of installing these piles might be to vibrate or drive them to the rock and then go and clean them out with a hammer grab and then go and drill the socket afterwards. But in this case, when you do use case advanced RC drilling, you can actually install it all in once. So you grab the pile that has a ring bit on it and you pull it up the drill string, kind of like you put your sock on your foot, and then drill it in. This is just a video giving you an example, kind of what it looks like. So how did the RC swivel come about? Well, Berminghammer is well known for vertical travel leads, which can take a crane a customer already has and make it into a foundation rig. Many people don't know that Berminghammer has made and stocks dedicated RC drills. All of them incorporate an RC swivel. So just going from left to right at the top there, we have one of our, there's been a couple models before this, but the BHD 40, the 40 just stands for 40,000 foot-pounds, BHD 80, 80,000 foot-pounds, BRC 75, BRC 32, BRC 100, and BRC 200. So the largest of the current model drills, which are on the bottom of that series, is the 200,000 foot-pound RC drill. Now you can see in the each of these later model drills what looks honestly like a RC swivel on top. So you see, I'm just going to bring out the laser pointer here. You can see this portion and then the discharge tube. That's an RC swivel right there, and then the discharge tube. So we manufacture drills that come with RC swivels in them, dedicated to do this type of work because we do it so much. So how did the RC swivel come about? Essentially, what it is our customers came to us and said, you know what, we have installations that are in and around 50 to 60 feet, and we have our soil drilling rigs. Can we use that? Just like you can put a foundation rig on a crane by using a lead system, you can drill hard rock on a conventional soil drilling rig by putting on an RC swivel. So that's where the idea was born. And here's just a little illustration or a little graphic showing the rotary transparently, and then the spindle we put inside with the RC swivel on top. So our first customer, this was on the east coast of the United States. I just want to show these pictures because it shows how essentially we replace the Kelly bar and put in what we call a RC spindle. So the spindle replaces the Kelly bar, and that's what's turned. And above that, you have your swivel and discharge. And that is essentially how the RC swivel came about. We're making them for our RC drills, and then we realized we could retrofit drill rigs with the same swivels. So just a little bit of terminology. I'm going to, again, bring the laser pointer out here. But going from the top down, we have our discharge elbow. If you can imagine, a lot of cuttings are coming up this discharge elbow, being turned at 90 degrees and then being turned another 90 degrees to come down. So what we've done is we've actually made on our RC swivels 2 wear pads that are hard faced that can be removed. So as these are being sandblasted all day from drilling, we do have replacement elbows that can go in, and when the plate's been worn down enough, they can be replaced. Below that, I'm just going to stay on the left side here. We actually have the RC swivel itself, and that connects to the rotary in 2 places. It kind of bears on a top surface here, but we have a torque reaction frame that connects the RC swivel back to the rotary, just so that it's not spinning with everything. And then below that, we have the spindle, which is the part that replaces the Kelly bar. And then below that, we have adapters to our various drill string sizes. Below the drill string, we have, especially in the application of down the hole hammers, we like to have a gate to be able to hold the pile in place and drill accurately on location. Now on the right side, we have our discharge hose, which then heads down to a cyclone, and that cyclone helps slow down the cuttings that are coming flying out of the discharge hose so that they can deposit gently into wherever you're going to deposit them, whether it's, again, a dump scour or a container or a pit. So I want to thank the engineering team for helping me put together this nice diagram, but it shows all the different applications that we have for the RC swivel. On the left, we'll start with the down the hole hammer. So at the bottom, after our drill string, we have a crossover and down the hole hammer. We've also used our RC swivels to go with large cluster drills. So down the hole hammers, typically we're going into up to about 48-inch. Clusters, we've gone as high as 11 feet in diameter with these systems. And the RC Auger is a new technology that I'm excited to talk about. I'll explain a little bit about that one later. So these are pictorially what they look like, but the next slide shows kind of what they are in real life pictures. So the first one I'm going to talk about is the down the hole hammer. You can see on the right slide here that this project was in New York City, and what they're doing were drilling, I think it was 30-inch piles up against this wall right here. and they were drilling right into rock almost immediately. So we have a down the hole hammer set up with a crossover, some drill string, the spindle, and the reverse circulation swivel installed into, I believe this is a Delmag RH28. And we have the discharge, which is headed back to a settlement tank in the background over here. So they, again, like putting a sock on a foot, they put the pipe with a ring bit onto the down the hole hammer and drill string. And you can see in this photo on the left that they were installing it. They're in mid-process or just starting to drill it down. So this next little animation was taken with permission from MinCon's website, but and the photo as well. One of the uses for this for the RC Swivel is to do these opal wall installations. So you can see they have pipe with interlock, and they get the next section of pipe with the interlock on it. Again, with the down the hole hammer, same idea as this previous slide, but with a connector to the next pile, and then they're drilling in rock pretty well immediately to install the pile and install the opal wall. Another application, this is a marine application. I put this photo on the screen here just because I wanted to highlight the discharge line. So again in black here, kind of following this line, they were bringing all of the cuttings to a storage location off camera. I found it kind of frustrating though. Not a lot of people like to take pictures of the the discharge tanks and storage pits, so don't get a lot of photos of those. So the setup consists mostly, again, our RC swivel up at the top, the drill string, and then we get down to the crossover. This is the piece that allows the cuttings that come up the side here to redirect and go into the center of the drill string, which allows that reverse circulation. Going from the bottom up, we have the drill bits, we have the down the hole hammer, a shock stub. In this case, we have a long extension, and we have a shroud on the outside. All of the cuttings would come off the bottom here with the air, come up along the side of the shroud, and then be redirected into the crossover and up through all the drill string and to wherever we want to store it. Cluster drilling is the second application that I want to talk about. This photo is is from a really interesting project, and I encourage you to look it up after. They've got a really cool web view where you can actually go into the tunnel. But in St. Louis, they were drilling a large kind of storage tank right in rock about 200 feet below ground so that they could deal with a problem that many cities deal with, which is storm events overwhelming their water treatment plants. So they were installing a really large, for lack of better words, a shaft horizontally 200 feet below ground, and that would store all of the combined waste and storm water that was overwhelming the system until they could treat it. So as part of that installation process, they needed a couple access and ventilation shafts. So the cluster drill that you see here was attached to our drill string and RC swivel on an LV36. And it was used to drill out what eventually was an 11-foot shaft to be with those ventilation and access shafts. It started, they did it in kind of a process. They did a 6-foot and then widened until they got to that 11-foot. They had a discharge pit just off of camera view again. They had a discharge pit where they had dug out an area, surrounded it with concrete blocks where all of the discharge would go settle, the water would seep out of it, and the remaining cuttings would be in that pit. So again, very similar to the down the hole hammer, just in this case, the cluster has its own internal crossover to allow the cuttings to come up the center of the pipe. And again, this is a video taken from the Center Rock site with permission, showing how the cluster works. So you have multiple down the hole hammers, and you have air feeding all of those down the hole hammers and coming back up, cuttings, water, and air going back up into the center pipe. So now we're going to talk about the RC Auger, which is a little bit of a newer technology that's come out in the past couple of years, and again, developed by Berminghammer. And in these videos that I'm going to show you, what I'm outlining is a process of cleaning out a pile. So whether it's an auger or whether it's a clean out bucket, when you have a pile installed, it could be in a marine environment, could be just on land like this, and you need to be able to clean it out. The process can be quite slow. So if you had multiple, let's say you had hundreds or thousands of these piles to clean out, you're constantly tripping back in and out of these piles to be able to clean them out. In marine environments as well, sometimes you'd use what's called a hammer grab to go in and clean the piles out. Again, it's a slow process because you have to go into the pile, take a little bit of material out, dump it somewhere, come back in. So if you have the RC swivel and drill string and an RC auger, what you can do to clean out these piles instead is go in one insertion. So you have, if you have, let's say it's an LB36 and you have roughly 65 feet of stroke, instead of having to trip in and out multiple times, what you can do is go with one insertion, use air, use water, bring all the material out at once, discharge it wherever you want to put it, and instead of having to trip in and out, going multiple times, taking a lot of time, you're kind of in and out of the pile very quickly. This can be especially useful in environments where you actually are already using down the hole hammers or clusters, because if you have 90% of the tooling and you want to use RC auger to clean your piles out before you get to rock, you can do that as well. So cool piece of technology. Again, it's very new within the past couple of years, but again, on jobs that have multiple piles that need to be cleaned out, and you wanted to accelerate your schedule a little bit, it could be a really useful piece for you. Now, the next thing that I promised to talk to you guys about were the ready to RC swivel rigs. So we've done quite a few of these conversions on multiple different rigs, multiple times, and I put together a list of all the different rigs that we've already done. It doesn't mean that we can't do others, as long as it's kind of common Kelly bar sizes, or you can get us a little bit of dimensions so that we can make a torque reaction frame. We should be able to retrofit most rigs that have a Kelly bar. So most rotaries that have a Kelly bar, we should be able to retrofit. But this is the ones that we've already done, so we have a pretty good understanding of. Just no particular order. We've done the LB28, the LB36, LB44. The spindles that you see on the right beside each one are the spindles that are associated with each one. For Bowers, we've done the BG24, 25, 28, 36, 39, and 40. And Delmag, RH26, RH28, and Yutong 280. So we've done all of these rigs before, some of them with multiple different spindle types. Those different spindle types address the different types of drill string that we were attaching. One thing that I wanted to kind of touch on here is that there's some commonality. Most of the rigs, I'm just going to use my my drawing tool here, but most of the rigs kind of separate the Kelly bar they use at around 28 and 36. So kind of below the 28s, you have Kelly bars that are typically in the range of 15.5 inches to 16.5 inches. And above that, you have Kelly bars that are typically in the range of 18.5 inches and above. So our RC swivels have kind of matched those two categories. So we have what we have now named the RCS 36. So again, that's for your conventional drill rigs that are 36 and up, and the RCS 28, 28 and below. So I should put little ups and belows. So the RCS 36 has a 12-inch center passage, and that just becomes important for the volume of cuttings that you're putting through. So if you have a really large cluster drill with a lot of cuttings coming back up, you want as large as a center passage as possible. Again, with the larger Kelly, you have a larger space to be able to have a larger center passage. So again, the RCS 28 has a 9 3/4 inch center passage. This is going into 15.5 to 16.5 inch Kelly bars. So these are the two main RC swivels that we have available to the market right now. And I just wanted everyone to understand kind of how they were positioned. So again, the RCS 36, 30, your rigs that are 36 and up, RCS 28, 28 and below. And with that, that actually concludes the main content part of this presentation. I got about 7 minutes left, so hopefully a little bit of time for some questions. But I would like some feedback on the presentation. Just on a scale of 1 to 3, if you could put into the chat how this presentation was. A 1 would be an example that you just got no value out of it. You kind of already knew all this stuff. 2 would be you learned something new that you might use one day. And if you could throw a 3 into the chat if you learned something that makes a lot of sense to implement. So if you can take the time just to throw a 1, 2, or 3 into the chat, it would be greatly appreciated. And just as I'm waiting for those, I will also point out that I am going to give another presentation on the 16th of January 2025. It sounds weird saying 2025, but wow, we're already there. And it's going to be on flying leads. So there's a QR code on the screen if you enjoyed today's presentation and you'd like to see another one similar. I'm going to try to keep them short, in and around the half-hour mark. And again, yeah, the QR code's on screen there if you'd like to join that. Now I'm going to hop over to the chat and just see if there were any questions that came in as well. I don't see any questions, but if you do have one and you want to unmute and ask, you can feel free to do that.
Hey, David. Sorry, yeah, it's David Delome from Mincon. Well, thank you for the presentation. It was very interesting. There's a lot of good things in there. Just wanted to make just a little thing that I wanted to add. When you talked about the down the hole technology, we go up to 60 inches, not 48. So the example, for instance, what you showed in France, the short video, was made with 53 inches. Just wanted to mention that.
Thanks, David.
But
yeah,
thank you.
There definitely is some overlap between the down the hole hammer and cluster sizes, definitely. Ray, you asked about a rat hole?
Yes, especially with the like the Bauer Delmag LRB rigs.
Yeah,
just to get the casing on the string.
Yeah, so you have to be able to, again, put the sock on the foot. So if you don't have the space, so say your pile is 40 feet and you've got about 60 feet on your mast, you have like another 20 feet there that you need to be able to get the sock on the foot. So you need to go below grade by about that additional depth. So in that case, Ray's just referring to drilling a small hole that you can put the pile in first to be able to have that depth. And yes, in the case that you need that depth, you would use a rat hole. In terms of penetration rates, we are in the process of starting to collect information for a database, but we haven't in the past. I'm sure someone like David Delorme from Mincon or any of your representatives for down the hole hammers could help in terms of guiding you in terms of how fast penetration rate you would get. I'm sure there's lots of factors that affect it, but maybe they could help you with some rules of thumb.
Hello, this is Sami Paavola from Robit.
Hey, Sammy.
Hello. That penetration rate, it depends the rock, but still it could be like 5 centimeters per minute, or let me see how much it's in inches.
Yeah, five centimeters is like 2 inches. 2 inches a minute.
Yeah, right. Approximately.
Yeah, it goes drilling with air in most cases goes from drilling meters per hours to meters per minute. Minutes, not minute, but minutes. So it's quite a drastic change drilling with percussion. I don't see any more questions just coming in, but I can wait definitely through the next couple of minutes if anything comes in. But if not, thanks guys for attending. And just a reminder, if you'd like to attend another one on flying leads, which is going to be talking about these leads you see on screen here, where we're hanging them, but they come with a lot of winches that run each of the tools, so they're a little bit more complex than just a swinging set of leads. If you want to see a presentation on when those are particularly useful, I will be giving that on January 16th. And thank you everyone that put in a rating. Very much appreciated.
Thank you for the presentation, David. Appreciate it.
It doesn't seem like I'm getting any more questions coming in. Oh wait, one new message. Oh, just a thanks. Okay. Yeah. If you missed it at the beginning, I'm just going to put up my contact card and I will stay on the line for a couple of minutes. If you want both my contact card and Steph covers South America and Europe. So our contact cards are going to just stay up on the screen and I'll stay on the line in case some people want to wait for a smaller group to ask some questions. But again, thank you all for attending.
Thank you.